Hi everyone and welcome to my channel. My name is Sam Yu and I'm going to be presenting and uploading videos related to the realization of my design project as a part of my electrical design course at the Memorial University of Newfoundland. I have been tasked with creating an Arduino-based security light system with light, motion, and battery voltage sensors and test input. I'll briefly introduce the project today, which utilizes the Elegoo Uno R3 board as well as the 37-piece Elegoo sensor kit, and I'll specifically go through the implementation of my first working circuit and the prototype for my design. My initial research found that I would be using several sensors in this kit, including a PIR sensor for motion, an LDR, a light-dependent resistor to detect the lighting in the environment, and a relay module to flip on a light when motion is sensed. To display the battery charge, I would use an LCD screen and a push button, which would both test the light and display the battery charge to the user. Connected on the other side of my relay will be two 12-volt 5-watt bulbs, which will be connected via a 120 AC to 9 volts DC adapter. And this was deemed appropriate as the bulbs only required about 3 volts each to power on during testing. I'll cover the circuit diagram and simulation steps in a future video, and for now I'll walk through the first working prototype of my system. As you can see here, each of the mentioned components are connected to my Elegoo Uno R3, which has been programmed to send a high signal to my relay when motion is detected in dark lighting conditions. Otherwise, the Arduino will remain in low power mode unless the push button is pressed, which will test input and flip the relay while displaying the battery charge. On this first breadboard, I have a 9-volt battery supplying my board at Vin, and it also sends 9 volts through a voltage divider, which I'm using to sense battery charge via one of my analog input pins. My photoresistor is supplied 5 volts by my board, which is sensing light and sending a signal to another analog input pin. The second breadboard here is powered by 5 volts from my board, which sends power to my push button and motion sensor, both of which send signals to my digital pins. Finally, my LCD screen is operating in 4-bit mode, and it also interfaces with the digital pins on my board to display the battery charge level when the button is pressed. With that understood, let's see the circuit in action and watch how the relay isn't triggered in the well-lit room until I cover the photoresistor with a box, simulating low light conditions. When I hit the push button, the light comes on to test the input, and it also displays the battery charge level. Note that although I'm not waving my hand here, my motion as I'm filming the video is triggering the motion sensor once the box is placed over the photoresistor. I'd like to quickly walk through how the Arduino code is used to get this circuit operational. So we start by including the necessary libraries for the LCD and power saving features. We then initialize the LCD with its connected pins and define the pins for a relay, PIR sensor, button, photoresistor, and LCD backlight. In the setup function, we configure the LCD, set the backlight to off for power saving, and set the relay, PIR sensor, and button as input or output as needed. We also attach interrupts to the PIR sensor and button to trigger specific actions when they're activated. In the main loop, we first read the light level from the photoresistor. Then we put the Arduino in a low power state using the low power function, and this reduces power consumption significantly until an interrupt occurs, which wakes up the Arduino. When the PIR sensor detects motion or the button is pressed, the respective interrupt handlers set the motion detected or button pressed flags to true. These flags are used to trigger actions outside of the interrupt handlers, and they ensure quick execution of the interrupt service routines and avoiding long operations that can block other interrupts. The isDark function checks if the current light level is below a certain threshold, indicating dark conditions. This is used to determine whether the light should be turned on when motion is detected. Back in the main loop, If motion is detected and it is dark, we turn on the relay to activate the light. The light stays on for 5 seconds before being turned off. This ensures the light only turns on when necessary, and this saves power. When the button is pressed, the handle button press function turns on the LCD backlight, activates the relay, and displays the battery charge as a percentage. Once the button is released, everything is turned off to conserve power. And that's how this code efficiently controls the circuit, using interrupts to react to motion and button presses while keeping power consumption down. Thanks for watching.